In 2024, the consensus was clear. The future of artificial intelligence would be written in the Bay Area and the Pacific Northwest. The strategy driving that consensus relied on massive scale. Companies poured hundreds of millions of dollars into training models, creating closed systems locked behind expensive, proprietary paywalls. By early 2026, the geographic center of gravity had cracked. Developers worldwide were suddenly wiring their applications into infrastructure originating from Beijing and Hangzhou. The immediate catalyst for this shift arrived in January 2025, with the launch of an AI model called DeepSeek R1. A relatively small firm proved it was possible to match leading global benchmarks without an endless supply of capital. Cutting-edge AI was no longer the exclusive property of a handful of American tech giants. Global LLM usage spiked. Chinese open-source models jumped from 1% to 3% in late 2024 to 30% by early 2026. The reason? DeepSeek R1 cost $6 million to train, a tiny fraction of the hundreds of millions spent on US models. This extreme price difference created a new benchmark for the industry. Developers realized they could get roughly 90% of the capability of a top-tier system for about 10% of the cost. The absolute performance records still belong to models like GPT-5, but most everyday coding tasks, summarizations, and enterprise workflows simply do not require the smartest possible system. The competitive landscape inverted. Success now depends on offering the leanest, most financially accessible digital infrastructure to a global market that values efficiency over raw, expensive power. How did these labs manage to build such highly efficient systems while facing intense international sanctions? U.S. export controls severely limit access to cutting-edge graphics processing units. Stripped of the ability to rely on brute force computing scale, developers in China had to invent entirely new, leaner software architectures to squeeze maximum performance out of limited hardware. They also benefit from drastically different economics. AI engineers in China earn significantly less than those in Silicon Valley, and provincial governments actively subsidize the land and electricity required to run major data centers. At the same time, strict domestic data and content regulations constrained purely experimental research. This forced labs to focus intensely on practical, application-centric designs that could be brought to market quickly. While major US players relied heavily on charging per use for closed APIs, Chinese tech giants like Alibaba aggressively released the weights to models like Qwen for free, under highly permissive open-source licenses. The lack of hardware access, paired with targeted government support, accidentally forged an ecosystem optimized for absolute maximum efficiency. Once these hyper-efficient models are published online, they immediately leave their origins in tech hubs like Hangzhou and spread exponentially across the internet. This map visualizes how those architectures travel. The qwen family alone has been modified and localized into more than 180,000 derivative models, with dense user clusters forming in Europe, South America, and across Asia. For a startup building a new software tool, deploying an open-source model directly on their own local servers means they can entirely avoid paying the unpredictable, compounding per-token fees charged by American hyperscalers. It also solves the problem of data sovereignty. Mid-market enterprises and European organizations bound by strict privacy laws like GDPR can run these models internally, guaranteeing their sensitive data never crosses international borders. Every single customized, locally run variation of these models serves as a quiet digital ambassador, weaving Chinese software architectures deep into the daily operations of the global tech economy. This proliferation is highly intentional. In the developing world, the Chinese government is actively engaging in AI diplomacy, signing memorandums of understanding and providing direct technical assistance. They are equipping these markets with highly capable, low-cost models tuned specifically for local languages, completely bypassing the predominantly English-centric tools exported by the US. And those digital brains are increasingly paired with physical bodies. These models are frequently bundled directly into Chinese-manufactured telecommunications networks, smart devices, and advanced robotics. By delivering the hardware and the software together, China is competing to establish the baseline digital norms and operating systems for the entire global South. This diagram illustrates how the enterprise market is actually settling. Companies are no longer forcing a binary choice between American and Chinese providers. Instead, they are building hybrid technology stacks. At the very top of the pyramid, highly expensive U.S. frontier models are reserved strictly for the most complex, high-stakes logic problems and advanced analytical tasks. But the massive foundation supporting the rest of the work, the day-to-day coding, bulk text summarization, and routine localized tasks, is increasingly handled by highly efficient open-source models. Any corporate strategy or national policy that assumes American algorithms will remain the default choice for every task is already outdated. The era of a single software superpower is over. In its place is a layered, multipolar ecosystem where any developer can deploy elite-level intelligence for a fraction of what it cost just 2 years ago.